The Therac-25 tragedy, a story of unseen danger.
Like, subscribe and share my YouTube channel for supporting our channel. Don't forget to hit the bell icon to get notified about latest spooky content.
Katie Yarborough woke up on a warm, clear June day in 1985. At 61, she had already endured 11 cancer treatments and was preparing for her 12th. As a manicurist, she was used to detailed, careful work, but today, the focus was on her health. She dressed and drove herself to the Keystone Regional Oncology Center in Marietta, Georgia. There, a state-of-the-art linear accelerator, the Therac-25, awaited her. This machine had treated thousands of patients before, delivering high-energy electrons or X-rays to target cancer cells. On this day, however, something went terribly wrong. As the machine started, Katie felt a red-hot sensation instead of the usual numbness. "You burned me," she told the technician, who assured her it wasn't possible. But the pain was real, and over the next few weeks, the damage became evident. Her breast had to be removed, and her left arm was paralyzed. Despite her injury, Katie continued to live her life and even drove herself around until she tragically died 5 years later in a car accident. Katie Yarborough was the first known victim of what would later be recognized as one of the worst software-related accidents in history. This is the story of the Therac-25 and the catastrophic consequences of trusting technology without fully understanding its potential for failure. The promise of radiotherapy. Radiotherapy, the use of high-energy particles or photons to destroy cancer cells, has been a cornerstone of cancer treatment for over a century. It offers a non-invasive alternative to surgery by targeting and damaging the DNA of cancer cells, thereby stopping their uncontrolled growth. Advances in this field led to the development of the Therac-25, a machine designed to deliver precise doses of radiation using sophisticated software to control its operations. The flaw in the code. In 1976, AECL Medical, a division of Atomic Energy of Canada Limited, developed a revolutionary double-pass linear accelerator. The Therac-25, a product of this innovation, was smaller and more advanced than its predecessors. Unlike older models that relied heavily on hardware, the Therac-25 was controlled by software. This software, however, was based on an older model, the Therac-20, and had not been thoroughly tested. In 1983, AECL performed a safety analysis on the Therac-25 but overlooked the need to rigorously test the software. This critical oversight would have devastating consequences. The software, written by a single hobbyist programmer who left the company in 1986, contained hidden flaws that could lead to lethal radiation overdoses. The first signs of trouble. 2 weeks after Katie Yarborough's initial complaint, a red mark the size of a dime appeared on her chest, with a larger disc on her back. Medical physicist Tim Still examined her and realized that she had been exposed to a dose far higher than the prescribed 100 rads, closer to 20,000 rads. This massive overdose was akin to standing inside a failed nuclear reactor. Despite this evidence, AECL dismissed the possibility of a malfunction and continued to deny any faults in the machine. A pattern of catastrophe. Similar incidents began to surface. A 40-year-old woman in Ontario, Canada, experienced tingling electric shocks during her treatment and later died from the radiation overdose. Another patient in Washington state suffered severe injuries, prompting doctors to start communicating and sharing their concerns about the Therac-25. Unraveling the mystery. The critical error, known as malfunction 54, was finally identified by Dr. Fritz Hager and his team. They discovered that if an operator made changes to the treatment settings within the 8 seconds it took for the machine's magnets to adjust, the machine could deliver a lethal dose of radiation. This flaw was compounded by the software's failure to check the actual setup of the machine against the prescribed treatment. Despite AECL's assurances and subsequent software updates, the Therac-25 continued to cause fatal overdoses. In one instance, a housekeeper task in the software, responsible for checking the machine's turntable position, failed due to an arithmetic overflow. This subtle and elusive error resulted in the death of Glenn Dodd in 1987. The aftermath. The tragic failures of the Therac-25 led to significant changes in how medical devices are regulated. Today, the FDA requires comprehensive documentation and independent verification of all software used in medical products. These changes were too late for the victims of the Therac-25, but they have helped prevent similar tragedies from occurring again. The Therac-25 story serves as a stark reminder of the importance of rigorous testing and ethical responsibility in the development and deployment of new technologies. It highlights the potential dangers of trusting technology blindly and underscores the need for constant vigilance to ensure the safety and well-being of patients. Conclusion. Katie Yarborough and the other victims of the Therac-25 paid the ultimate price for the failures of a system that placed too much trust in untested technology. Their stories remind us of the human cost of such oversights and the importance of learning from past mistakes to build a safer future.